So we're going to go ahead and talk about the first piece of evidence, and if you're looking at your PDF document, it looks a little like this. Number one, fossil record. So when we're talking about the fossil record, we are talking about the physical record of history of life on Earth. We talked about the fossil record, or you should have learned about the fossil record when we were talking about the history of life. So most of our understanding of how life has changed over the 4 billion years of Earth's history has been through the fossil record. And there was a gentleman named Charles Darwin who did a lot of observations of the natural world, and he proposed that many species have come into existence and have lived their life and then have vanished over time. And the process of that explanation is based on the fact that he was comparing fossils from older rock layers in the earth and showed that these changes have taken place over time. So an example of something like that is called, comes from the horse. The fossil record of the horse is something that you're going to look at when you look at your worksheet that we're having you do today or this week. And when we look at the fossil evidence of the evolution of the horse over the last 54 million years, what we notice is that there's been quite a few changes to the horse of today versus the horse from 54 million years ago. One of the biggest changes that you can see by looking on the right side of the screen is the change in the toes of the horse. So the evolution of the horse has changed the amount of toes that a horse has on its foot. And now the current horse of our current time period has one toe, and it basically stands on its toenails when it is walking on the ground. Another fossil that helps us to see the transitions that's going on between species is Archaeopteryx. It's one of my favorite fossils. And Archaeopteryx is actually a fossil of a reptile. This particular reptile, though, had feathers. And if you look closely at the fossil in this image, you can see what outlines to be feathers. And in fact, one of the really cool things about what I've experienced in my life is I went to Stanford for a summer to learn from different professors there. And one of the professors I got to hear speak was a professor who actually tested this actual fossil to determine that the elements in the rocks next to where the feathers would be actually came from feathers. So he has provided evidence to show that they were actually feathers. So all of this fossil evidence brings us to something called the concept of transitional species. And we see these transitional species only through fossils because we can't see these transitions in our lifetime. So when you're looking at the examples below, you can see that the nose on these transition fossils has moved from the front of a dog, wolf-like creature to what we know today being the gray whale, which his nose is on the top of its head. And so we're able to find these transitions of fossils that show us the transition of how the structures in the organism or species changed over time. The next thing that we're going to talk about is geographic distribution. Geographic distribution is here on your notes. Geographic distribution is basically dealing with species living on different continents. And these species all live in very similar environments. For example, they might live in a tropical rainforest in South America, or they live in a tropical rainforest of Asia. And because they live in these similar environments, they end up looking physically alike. We call this convergent evolution. Now, you guys have done an activity already dealing with Pangea, and one of the evidences to help us support the fact that the continents all came together is actually evidence that also helps support evolution in this concept of geographic distribution. So let's talk about convergent evolution for a minute. When we look at a shark and we look at a dolphin, understand one is a fish, the shark, and another is a mammal. But many of the structures on these two very different species, being very distantly related, are very similar. The top fin is very similar, their bottom fins are very similar, their overall body shape is very similar. Some other examples of shapes being similar also come from fish. If we look at some of their fins, the shark, for example, the bones in that fish fin are very similar to the bones of a mammal's fish, or a mammal's fin. The same is true of the bones of a bird, or even the bones of a reptile who's now extinct, Ichthyosaurus. So these are all convergent evolutions because they all live in a similar environment, that is the environment of water. They all developed a similar type of limb. This is an example of convergent evolution. Here's an example from Pangea. For example, we have two animals, the giant anteater from South America. It was in a environment that's very similar to the environment found in Africa of the giant pangolin. So they have a very long snout that helps them eat the same type of animal, which are insects. In this case, ants or small crawly things. This is an example of how the geography can distribute similar traits, allowing animals to evolve these traits. They are not related to another, but it's because of their environment that they are evolving similar traits. The next thing that we're going to talk about is anatomy and development. In anatomy and development, you can see that there's different things. I'm going to go ahead and take a break here at this point so that if you wanted to go do something else, you can, or if you would like to just stick around and listen to the next video, you can do so as well.